In this section, we're going to be talking about inverses of square root and quadratic functions. And if you remember that an inverse is gotten by taking your y value and your x value and just simply switching those two things and then solving for y. That's how you get an inverse. So the things that we're going to be doing with this is we're going to take our function, we're going to graph it, find the domain and range of that, then we're going to algebraically get the equation for the inverse and find the domain and range of that, as well as graphing the inverse. All right, so let's start out with graphing this function. All right, so this is a square root graph that has been shifted left 4 units and down 5 units. So left 4 and down 5 units. And then if we want to get some other points on this, we can figure out a table of values here. We know -4 will produce -5. Well, if I plug in -3, because I know my square root graph is going to go to the right, so -3 plus 4 is 1. Square root of that is 1. Minus 5 is -4. So -3, -4 will be on our graph. If we let x be 0, sorry, not -0, just 0, because 0 will work out evenly here. 0 plus 4 is 4. Square root of 4 is 2. And 2 minus 5 is -3. All right, so there's 3 points that we can use to sketch the square root graph going in this direction. All right. Now, if I want to figure out the domain on this, well, your domain is from left to right, so your domain is going to be bracket -4 to infinity, and your range is from bottom to top, which would be from -5 to infinity. All right, so if we graph the inverse of this, well, the inverse we can get by simply switching the x and y coordinates. All right, so the coordinate right here is -4, -5. So if I switch those coordinates, that would be -5, -4, which would be located right here. All right, so let's put a point right there. This coordinate was -3, -4, so that means -4, -3 would have to be on the inverse. And this coordinate was 0, -3, so that means -3, 0 would have to be on this graph. All right, and we can sketch the graph of this going up. Now, one of the things to remember is that these two graphs are reflections over the line y equals x, which goes right through here. All inverses are going to be reflections over that line. So visually, if your graph does not look like a reflection, then you know that you did something incorrectly. All right, so what is the domain for this orange graph, which is our inverse? Well, the domain would be from -5 right here, from -5 to infinity. And the range would be from right here, the y value, which is -4 to infinity. Now, one of the things to notice is that your domain of the original function becomes the range of the inverse function, and the range of the original function becomes the domain of the inverse function. And that is simply because the x and y values have been switched. The x's become the y's, and the y's become the x's. Okay? All right, so now let's figure out how to get the equation of the inverse. All right, so the equation of the inverse, we start by taking the original equation, which is y equals square root x plus 4 minus 5. And we're going to switch the x and y values. So that makes it x equals square root y plus 4 minus 5. We'll add the 5 over to the other side. We now need to get rid of the square root, so you're going to square both sides. Now when you square both sides, that does not mean square the x and square the 5. It means you're squaring the entire side of the equation. So it's x plus 5 quantity squared. And when you square a square root, that cancels it out, leaving you with y plus 4. And the last step is to subtract the 4 to the other side. So that's going to give you x plus 5 squared minus 4 equals y. And y is the inverse, so we replace it with the notation for an inverse. Okay. All right, so that is your equation for the inverse. Now, the inverse equation represents a parabola, and really this is not the entire parabola, this is just the right side of our parabola. So it really has been restricted because the original was only half of this. Okay. All right, so let's take a look at going the other direction. Now we are given a quadratic equation, and we want to do the same kinds of things. All right, so let's start out by graphing this quadratic equation. So the vertex has been shifted right 3 units and up 2 units. So let's just go ahead and start right there. Right 3 and up 2 is here. And if we want to make a table of values, just to make a quick graph here that's a little bit more accurate, we know 3 2's on the graph. Let's try when x is 4. All right, so 4 minus 3 is 1, squared is 1, plus 2 is 3. So 4, 3, and its symmetric point are on the parabola. All right, let's go with 5. 5 minus 3 is 2, squared is 4, plus 2 is 6. So 5, 6 be here, and its symmetric point would be up here. All right, so if we sketch our parabola now, looks something like this. Now, if you look at your domain of this, your domain would be from negative infinity to positive infinity. Now, what we need to do with this is we need to understand that this graph is a function, but this graph does not pass the horizontal line test. The horizontal line test tells you if the inverse is a function. And since a horizontal line is going to cross this graph in more than one place, that means our inverse is not a function. So what we have to do with our parabola is we have to restrict the domain. Simply put, that means we need to cut off part of our parabola. Now, if we just take off this much of it, That's not enough because our graph still does not pass the horizontal line test here. If I take off a little bit more, still does not work because it will not pass the horizontal line test down here. We need to restrict it all the way back to the vertex. Now, no matter where you draw a horizontal line, it will pass the horizontal line test. It's only going to cross this graph once. That means the inverse of this will be a function. All right, so that's where this thing called domain restriction is going to come into play here. The domain restriction here is going to be from 3 to infinity. And the range of this is 2 to infinity. Now if we plot the inverse points, we have 3, 2 is on this graph, which means 2, 3 would be on the inverse. 4, 3 is on this graph, which means 3, 4 would be on the inverse. And we have, let's see, 5, 6 is on this graph, which means 6, 5 will be on the inverse. So 3, 4, 5, 6, 1, 2, 3, 4, 5. So this would be the graph of the inverse, which we can see the domain is from 2 to infinity, and the range would be from 3 to infinity. Once again, the domain has become the range, and the range has become the domain because of switching x and y. And you can see that this is a reflection over the line y equals x. Okay. All right, so algebraically, how do we find the inverse equation? All right, so let's rewrite this equation as y equals x minus 3 squared plus 2. Switch the x and y. Now we solve for y. All right, so you're going to subtract 2 over to this side. We now need to get rid of this square, and so we take the square root of both sides. So it means you'll get the square root of x minus 2, and then the square root of the right side just leaves you with y minus 3. And then adding 3 over to the other side gives you square root x minus 2 and then plus 3 outside of the radical equals the y, which we write as f inverse of x. That is the inverse notation. And you can notice that the inverse graph is a square root graph.